All right, now that we've talked about solutions and given you some details about what it means to be ideal, let's talk about what it means to be not ideal, okay, and how these different attractions and repulsions can affect the properties of these solutions. In a non-ideal solution, okay, there are other things at work besides just the equal magnitudes between the intermolecular forces, right? When it was ideal, I said, well, I can't completely disregard or ignore these intermolecular forces, but I'm going to say that they're the same, right? They're just as strong between the solute and the solvent as they are between the solute and the solute and the solvent and the solvent. But it's possible that these magnitudes are different, okay? Maybe the solute and the solvent are actually attracted to each other more than just solute with solute or solvent with solvent, in which case delta H3, which represents the interaction between solute and solvent molecules, it's actually greater than delta H1 and delta H2 between solute and solute or solvent and solvent, in which case the total delta H is going to be negative, right, exothermic, and the change in volume of the solution is going to be less than 0 as well, which basically means that the volume will shrink a little bit. This sometimes sounds strange to people, but basically what this is saying is if you had 10 milliliters of this solution and 10 milliliters of this solution and you mix them together, okay, it's possible that the total volume is a little bit less than 20 if there's a strong attraction between whatever's in this container and whatever's in this container, right? They're attracted to each other, they get closer together, so now the volume shrinks a little bit. Opposite situation is also possible. Intermolecular forces between them are weaker than the individual intermolecular forces, in which case delta H3 is actually less than the sum of delta H1 and delta H2. So here it's overall endothermic, and the volume may actually increase a little bit, okay? And actually, if the forces are much weaker between the solute and the solvent compared to solute with solute or solvent with solvent, it's possible that the solution will never form at all, okay? Think of something like oil and water. They just don't mix. And the reason they don't mix is because they're so different from each other, right? There's no favorable interaction between the oil molecules and the water molecules. The oil wants to stay with the oil, the water wants to stay with the water. You bring them together, there's no real strong attraction between them, so they prefer to be further apart and separate.